Hello and welcome to my tutorial on streamlines and flow. So streamlines are stable flow lines. Fluids are things that flow like liquids or gases, and when the fluid flows, different parts of it may move in different directions and at different rates. So fluids are made up of things called fluid elements. Now this is just a technical term for the part of the fluid where all the particles are flowing in the same direction and at the same rate, so they must all have the same velocity, and each of the fluid elements are small enough so that it flows without breaking up, but large enough so you don't have to consider the random movement of the particles within it. Spot the obvious spelling mistake, E when you spell particles. But anyway, the path a fluid element can take is called a flow line, and if every fluid element follows the same path, then the flow line is stable, and it's also known as the streamline. So streamlines are parallel in laminar flow. Laminar flow is a flow pattern where all the fluid elements flow in the same direction. And the result of this is that all the flow lines are streamlines that run parallel to each other. Laminar flow usually occurs when the fluid is moving slowly, and the diagram is on the next page. So laminar flow is when all of the flow lines are in a straight pattern, so they're run all along the length of the pipe. Flow lines are unstable in turbulent flow. It's when a different pattern occurs when the fluid elements get mixed up. So if I had an eddy current, for example, here's a rock, and the water is having to flow around it, so it's kind of forming these turbulent flow lines because it has to go around it, so it's not quite straight anymore, but it will always try to retain that straight flow. If you go to your local stream, if you have one, you will notice this as the water passes over the rocks. You can't see it terribly well in low light, but you can see it very well on a nice clear sunny day. So that's basically what that bullet point is trying to say in a picture. So turbulent flow usually occurs when a fluid is moving quickly. In turbulent flow, the fluid often moves around in miniature whirlpools called eddy currents, and both types of flow is needed if the fluid needs to flow smoothly through pipes and with a minimum amount of viscous drag. More about that in the next tutorial on viscosity. Turbulent flow is needed if fluids need to be thoroughly mixed. So move on to the next page. I can show you the diagram now. So this straight line is to show the laminar flow. So when fluid elements move past each other with different velocities, there is a force of friction between them. Friction opposes motion, so the force acts to slow the force. The force of the friction produced by a flowing fluid is called viscous drag. The size of the force depends on the viscosity of the fluid. The higher the viscosity, the larger the force, and viscous drag is much larger when the flow is turbulent. So water moves faster when represented by the blue arrow here, but a lower velocity is the red arrow, and the water here has a smaller velocity because the arrow is smaller. That's what I've also tried to do a bit down here. So this set of water particles moving faster than this one, this one, this one, this one, and this one being the slowest. So now, if we have a look at a little question. In Willy Wonka's chocolate factory, melted chocolate flows through a pipe into a large container where it is mixed with other ingredients. So, using a diagram, describe the flow of the chocolate in the pipe. When the chocolate is in the pipe, it flows fairly slowly. Explain why this happens, and describe how the flow changes when the chocolate enters the mixing container. So I'll give you a quick 5-second pause, flick back through the video if you didn't quite get what I just said, and if you're still stuck, try watching the video again. Right, so I'll give you a 5-second pause. Okay, so the chocolate in the pipe is undergoing laminar flow. So if this is the pipe, so if you use straight lines to represent the flow of the chocolate, then your streamlines should look a little something like that, with one arrow having the highest velocity and two smaller arrows with lower velocities, just like the diagram that I showed you a few seconds ago here. And chocolate is highly viscous for part B, and its rate of flow is limited by a large viscous drag force. It's a frictional force caused by fluid elements in the chocolate moving past each other with different velocities. When the chocolate enters the mixer container, the flow pattern changes to turbulent flow, and the fluid elements within the chocolate get mixed up and the flow lines become unstable. To add to part B, that was the point of the diagram where I showed you this blue arrow and the red arrow. So they can undergo friction like that. So okay, that's it for this tutorial. I hope you found this useful, and thank you for watching.